In this section, we are going to look at the interpretation of the laboratory results. You have already done your soil sampling, you have taken to the lab, testing has been done, and now the laboratory has given you the results, and now it will be the interpretation of the results. And this is usually done by agronomists who are experienced in terms of soil science, or maybe soil scientists who can be able to interpret the results as given by the laboratories. And remember, when you are doing the test, or when the test is done, there are several things that are looked at. The result will basically have several things, and one of it is a result on the NPK, that is the main fertilizers, nitrogen, phosphorus, and potassium, and also the micronutrients. That will be one of the results that is given, whereby the result will be with either of this nutrient, the deficiency that is there, and the recommendation in terms of the amount of nutrient that is needed for the particular land where testing was done. The next thing will be that will be given, the result will contain is the pH value. It could either be from maybe 4 to around 8, because most of the soil range from around 4, a pH of 4.0 to a pH of around 9.0. So in between, it's going to be given to show whether your soil is acidic or it is alkaline, and recommendation, or whether you are going to use lime to reduce the acidity, or maybe you are going to use acidic fertilizers to be able to reduce the salt accumulation, or the alkalinity in that soil. The other factor that the result will have is a textural class. And the textural class, as we said, the texture is the relative mixture of the sand, silt, and clay in a particular soil. And your soil will be able to be given a textural class. Suppose maybe it is given as sandy, definitely you know the drainage will be high, meaning there will be loss of nutrients, and you'll be able to, it will mean you'll have to apply the nutrients in bands. You don't just do one application of nitrogen, but you apply in splits, maybe 3 splits, because there is depletion, there is leaching of nutrients in such a soil. And the other thing will be given is the bulk density. The bulk density of this soil will be given, and depending on the results, if the bulk density is high, above the standard, it will mean that your soil is too compact, and which will mean it may be prone to flooding or to waterlogging. If the bulk density is high also, it may mean penetration of the plant roots will also be a challenge. But if the bulk density is low, it will mean there is aeration, the root will be able to penetrate better, and also you find that the plant may grow well. The other factor that the result we have is a CEC, that is the cation exchange capacity, and basically this is the capacity of the soil to hold the nutrient. And therefore, if the CEC is too low, you know the nutrients in your soil, the capacity of that soil to hold nutrient and to give this nutrient to the plant will be low. And therefore, those are the factors that we are going to look at. And once we look at these factors, we are going to tell you how to interpret some of these factors, so that when you get the lab results, either you are able to interpret yourself, or a soil scientist or an agronomist will be able to interpret for you, and you will be having the information on what is written in that laboratory soil test results. We are going to look at a parameter. The first parameter, as we talked about, are the main nutrients that are required in plant, and we are going to look at nitrogen. And when I look at nitrogen, nitrogen interpretation is given in either excess or low nitrogen. Those are the interpretation parameters, and it is usually given in percentage. So if the level of nitrogen is 0.25 and above, it means the level of nitrogen in your farm is high. And if the value is given as 0.05 or less, it will mean the level of nitrogen in your farm is low. And therefore, those are the parameters that are given. In terms of fertilizer recommendation for nitrogen, it is recommended in unit area of land, and the unit area of land may be an acre or maybe a hectare. And you're going to find, for example, the lab recommendation may give a recommendation of nitrogen as 100 kg of nitrogen per acre or per hectare. And the lab results for nitrogen is usually given in elemental N or elemental nitrogen. But you find commercially, the companies that produce fertilizer, you find most of the time, nitrogen is represented in the form of ammonia. That is NH4. That is ammonia as ammonia. And you find when you want to convert from what is given in the lab to what is available commercially, then you have to do a conversion, and you are going to look at this conversion later. The other nutrient we are going to look at is phosphorus, which is given as P. Phosphorus is usually given in the recommendation as low, moderate, or high. And the unit of measurement for phosphorus is milligram per kg of soil. And you find for measurement, which is 10 milligram per kg of soil or less, this is regarded as low phosphorus in that soil. And if you have a measurement of 10 to 20 milligram per kg of soil, you find this is regarded as moderate. And if you have 30 or more milligrams per kg of soil, this is regarded as high. And therefore, once you have this recommendation, those results, then we have the recommendation. And the recommendation will be in form of kg per unit area of land, which could be an acre or per hectare. For instance, you could be given a recommendation of 100 kg P, that is kg phosphorus per hectare or per acre. This is given in form of the elemental P. And you find in the market, the fertilizer manufacturers usually present their phosphorus in terms of phosphorus pentoxide. And therefore, you have to do a conversion to be able to know how many bags. Out of this recommendation, you'll be able to know how many bags you are supposed to apply per unit area of land. The next product or the nutrient you're going to look at is potassium, which is represented as K. The measurement of potassium is given in centimoles per kg of soil. And here it is given in a small measurement because a cent is 100th of a unit, and you find the mole is a measure of unit. So it is 100 of that measure, which is a mole. And you find for potassium, they usually what we call conversion factor. If you are given in moles, then in order for you to convert from the centimole per kg of soil that you're given to milligram per kg of soil, then there is a conversion factor that is used. And in this case, for potassium, there is a conversion factor of 390. And you are going to find it is not only potassium that has a conversion factor. Calcium has a conversion factor of 200. Magnesium has a conversion factor of 120. And sodium has a conversion factor of 230. So this is a conversion factor when the measurement is given is in centimole per kg of soil. And you want now to convert this into milligram per kg of soil, because once you convert this into milligram per kg of soil, you will be able to convert from this measurement into the measurement that we are referring, which is the commercial measurement that is given in bags, which is in the form of potassium oxide. For potassium, commercially it is represented as potassium oxide. And remember, the lab results will give you in form of the elemental K. Suppose maybe you are given the measurement. The lab result says your soil has 2 centimole per kg of soil. That is the lab results has given that. You have to convert this into milligram per kg of soil. And here you just take 2, multiply by 390. 390, remember we said that is the conversion factor for potassium when you are converting from centimole per kg to milligram per kg. And this therefore will give you 780 milligram per kg of soil. That is 780 milligram K per kg of soil. And therefore, once you have this conversion, it will now be easier to convert into the commercial form of fertilizer that is given by the manufacturers in bags, that is sold in bags commercially, which is in the form of potassium oxide. It is important to note that when you are dealing with cations, which is basically the metals of metallic, which for instance maybe could be copper, sulfur, zinc, manganese. So all those nutrients, they are usually given in terms of the measurement centimole per kg, centimole of that nutrient per kg of soil. That is a standard measurement. And all these have conversion factors where you have to convert into milligram per kg so that you are able now to convert into the commercially available form of that nutrient.